Okay, now coming to the next part, that is the Gibbs-Turner equilibrium. Now, what does the Gibbs-Turner equilibrium states? It states that when two compartments, suppose this is compartment A and this is compartment B, are separated by a semi-permeable membrane. What I am drawing in red is the semi-permeable membrane. Then both the compartments tend to be electrically neutral. That is, compartment A will be electrically neutral and compartment B will similarly become electrically neutral. Now what does this mean? This means that the number of cations and anions in the compartment A will balance itself, as well as the number of cations and anions will balance themselves in compartment B. Why does this happen? Because of the redistribution of ions via the semi-permeable membrane, which is supporting the two compartments A and B. To understand this, we will take one example. Suppose again there are these two compartments, compartment A and compartment B. They are separated by a semi-permeable membrane. Now, suppose in compartment A there is positive cation, that is sodium, and anion, that is chloride. In compartment B, suppose there is cation, that is sodium again, and anion, that is chloride. Then, according to the Gibbs-Turner equilibrium, the amount of sodium ions, that is cations, in compartment A would be equal to amount of anions in compartment A, and this will render the electrical neutrality for compartment A. Similarly, number of cations in compartment B will be equal to number of anions in compartment B, which will help in making the compartment B as well electrically neutral. Now, we can write this as cations in compartment A, and if we take product of cations in compartment A and anions in compartment A, then that product will be equal to the product of cations in compartment B and anions in compartment B. This is because there is redistribution of ions, as this semi-permeable membrane is permeable to sodium and chloride. The sodium and chloride adjust itself such that both the solution become electrically neutral, both the solution don't have a specific charge. This is due to redistribution of ions. And when we take this product in the solution A, it will be equal to the product in the solution B, because the number of ions have redistributed themselves in such a way that the product which comes, this product, that is the product of cations and anions in solution A, whatever may be the charge here, would be equal to the charge which we are going to see in the compartment B. Now, moving ahead. So, as you know, that things aren't perfect in life, and so are things not perfect in our cell body. Suppose we take two cells or two compartments, A and B again, which are separated again by semi-permeable membrane. Now what we do is we add cations again in one compartment, anions and cations in B, as well as anions. Now what we do is we add a molecule X, that is an anion. Okay, so I have added an extra molecule X, an anion, in the compartment A. X molecule has negative charge, same as the chloride. Now what will happen? Now again there will be redistribution of ions, that is sodium will go here, some sodium will come here, chloride will come here, and chloride will come here as well. In order to make the solutions A and B electrically neutral according to Gibbs-Stoner equilibrium. So what we will see is that in solution A, the amount of cations, that is sodium, would be equal to the sum of anion chloride plus the X molecule. While in solution B, we will see that the number of cations, that is sodium, would be equal to the number of anions, that is chloride. Because this X molecule is not permeable, that is it cannot go here because of its size. So that is why the sodium in the A compartment is balancing the X molecule. But the B compartment does not have the X molecule, that is why the sodium in the B compartment only has to balance the chloride in the B compartment. Now, what does this mean? This means that as more sodium would be required to balance out more number of anions, so the sodium in A compartment has become greater than sodium in B compartment. Similarly, the chloride in B compartment is greater than chloride in A compartment. Why is that? Because less number of chloride is required to balance the sodium in the A compartment. So in A compartment, what is happening is less number of chloride is required to balance the sodium ion. While in B compartment, more amount of chloride is required to balance the sodium. Because here, not only chloride, the X molecule is also available to balance the sodium. And hence, as you can see, there has become a redistribution of ion. Why? To achieve the electrical neutrality. So up till now we have seen two properties. One is the selective permeability of the membrane. Because of the selective permeability property, some molecules are very easily permeable, like in this case sodium and chloride, while some molecules are not permeable, that is the X molecule in this example. Now, due to this, there is redistribution of ions to achieve electrical neutrality according to the Gibbs-Stoner equilibrium, and this will lead to redistribution of ion. Now, how will this lead to formation of RMP? We will see further. Now we will see another important point, that is the role of sodium potassium ATP sperm in formation of the resting membrane potential.